In this video, I'd like to cover a review of formulas to names and names to formulas of ionic compounds. We're going to cover three options that takes place with ionic compounds. So I'll put formulas and names. So names to formulas and formulas to names. For the first, I would say standard ionic compounds. This is where you are dealing with simply a metal element that can only have one type of charge and a non-metal element that can only have one type of charge. So for instance, let's take Mg, for instance. Mg is in column 2A. It can only be a 2+ charge. Chlorine in column 7A, it can only be a 1-. Or K can only be a 1+. S can only be a 2-. So if we looked at K with a 1+ because of column 7A, and S with a 2-, the formula that we would get, we would need another K. So the formula we would get would be K2S. 2 Ks for 1 S. And the name that we would get is potassium, because K is potassium. And then instead of sulfur, because it came from the periodic table, we would go sulfide, potassium sulfide, a standard ionic compound. If we looked at aluminum and oxygen, aluminum is a 3+, column 3A, and oxygen is an O with a 2- because of column 6A. So if we put these together so that they finally cancel each other out, we get a 6- and a 6+. We have 2 Als for 3 Os, and we call this aluminum oxide. Oxygen gets changed to oxide. We also have ionic compounds with a metal that has multiple options for the positive charge. So now we're dealing with ionic compounds in which the metal has multiple options. Most of the time, these are transition metals. There's a few over here that would not be considered transition metals that have multiple charges. So if we looked at Ti, Ti can be a 2+, 3+, or a 4+. Vanadium can be a 3+, 4+, or 5+. Now, we only use Roman numerals to identify the charge when there are multiple charges that it can be. For instance, scandium can only be a 3+, so we would not use a Roman numeral there. So let's say that we have this formula of Ti2S3. Ti2S3, and we wanted to know its name. What we would need to do is list out 2 Ti's, because it's Ti2. We would list out 3 S's, but when I go to find the charge on the Ti, I don't know what it is. It's either a 2+, 3+, or a 4+. But I do know what the charge is on S. S is in column 6A, so it has 6 valence electrons, so it's got to be a 2 minus. So S being a 2 minus, S being a 2 minus, S being a 2 minus. If these add up to a 6 minus, then each one of these must be a 3 plus, because they told us there were 2 TIs and 3 S's. So I go to my chart. Is that an option for TI? It is, 3 plus. Now that I know that it's a 3 plus, when I name it titanium, I must include a Roman numeral 3 because of the 3 plus, then sulfide, IDE at the end. Titanium 3 sulfide. Notice up here, I did not use Roman numerals because the charges on the metal ions, there are not multiple options. But now, titanium has multiple options. So we have to identify the charge based off the name. In this example, we're going to look at FeCl3. Since the formula is FeCl3, we know that we have one Fe and 3 Cls. When I look up Fe, Fe can either be a 2 plus or a 3 plus, but we know that Cl has to be a 1 minus. So I'm going to look at the non-metal first with the 1 minus, and the 3 Cl 1 minuses add to a 3 minus total. So that means the 1 Fe must be a 3 plus. So the name of this would be iron. Because iron may have a 2 plus or a 3 plus, I have to identify it as a 3 plus, and then chloride on the end. If we were moving from the name to the formula, for instance, let's say that we have the example of nickel 2 oxide. Well, nickel 2 oxide, nickel, Ni is a 2 plus because of the 2. Oxide comes from oxygen, which is a 2 minus. So then the formula would just simply be NiO. Notice the Roman numeral is not needed, nor should it be used, because we can deconstruct the formula to the ions to come up with the name, but when we name it, we have to use the Roman numeral. Let's say that we have platinum with the Roman numeral 4. A V is a 5. The one before the V is a 4. Sulfide. Well, platinum with a Roman numeral 4 is a PT with a 4 plus. Sulfide comes from sulfur, and that's in column 6A, so that's an S with a 2 minus. It turns out that I need another S with a 2 minus to balance the 4 plus. Because of that, the formula is going to be PTS2. Name to formula, formula to name. Finally, the last piece is ionic compounds. Including polyatomic ions. Ionic compounds including polyatomic ions. So let's say that we have this Mg3PO4 2. This comes from 3 mgs, and every mg is a 2 plus because of the column 2a. The PO4, there are 2 groupings, 1P with 4 O's, 2 groupings of PO4 with that 2 on the outside. For polyatomic ions, you have to use parentheses when you have more than one of them. And we have to use the back side of our periodic table in order to know what the charge is going to be. And in this case, it's a 3 minus. So 3 minus, 3 minus. So now, 2 plus 2 plus 2 plus is a 6 plus. 3 minus 3 minus is a 6 minus. And the name is going to be magnesium phosphate. Magnesium phosphate. If we are doing the opposite and moving from the name to the formula, aluminum is an Al with a 3 plus. Nitrate, notice we are not looking up nitrogen because if it came from nitrogen, it would have been called nitride, but it's nitrate. So we go to the back side of the periodic table, and we look up nitrate, NO3, 1N with 3 O's, and it's got a 1 minus charge. So then we need 2 more to be able to balance the 1 Al. Because of that, the formula becomes Al. I need 3 NO3s, so I need to put it into parentheses, and then on the outside, put a 3. I hope this helps in understanding the 3 categories of ionic compounds and moving from the name to the formula for each.